Welcome students. In this video we are going to talk about the lever arm rule. The lever arm rule. So for what reason it is used? It is used to calculate the phase fractions. Okay, it is used to calculate the phase fraction or amount of the phases present in a given system. So dear students, for this understanding I am going to have again the isomorphous system of two metals A and B. There are two elements A and B in the isomorphous system. So let us have this isomorphous phase diagram here, isn't it? So I am having, this is liquidus, this is solidus, this is element A and B, this is composition of X in B, this is liquid, this is liquid plus alpha, and this is solid. This is temperature of A, melting temperature of A, and this is melting temperature of B. Okay, so dear students, here I am going to select the composition at 50%. So if I take here the composition of say 50%. Okay, now if I have here, of course this will be the solid, this will be liquid. Then of course I am having the tie line here. Okay, and with this tie line, see, I can have here the composition in the liquidus, and here is the composition in solidus, isn't it? Here I can have the volume fraction in the liquid. Say here it will be Vs, so Vl, and here is the volume fraction in the solid, isn't it? And the summation of these two will be 1 only, isn't it? That is volume fraction solid, volume fraction in or of solid, which plus the volume fraction of liquid must be equal to 1. That is, I can write Vs plus Vl should be equal to, and I am saying that overall composition is capital C. Overall composition is capital C. Then what will be capital C will be equal to the volume fraction in the solid into composition in solid plus volume fraction in the liquid into composition in the, isn't it? So therefore the mass fraction of element B in alloy will be how much? That is equal to what? Or I want to write the VL will be equal to, from this equation number say 1, VL will be equal to what? 1 minus Vs, isn't it? So for that, put here in this equation 2, what we are going to put here, that is VL is equal to 1 minus Vs. So what we will get here? So capital C is equal to Cs into Vs plus Cl into 1 minus Vs. So solve this, Cs into Vs plus Cl minus Cl into Vs, isn't it? So what we can do here? So CS, see this is Vs and here is Vs. I can get this Vs out into bracket CS minus CL plus this is C into CL, isn't it? So dear students, if I want to find out, and this is equal to C, so if I want to find out the volume fraction of solid, that is Vs, I can now able to find out. So what we can write here, Vs is equal to this C minus Cl divided by this Cs minus C, isn't it? So you get here the volume fraction in solid. Now put this value of 1 of Vs in equation number 1, you will get the volume fraction in liquid as say Cs minus C divided by Cs minus C, like that. So anywhere you can see here, if I put my fulcrum here, and these are the volume fraction in solid or liquid, and this is the volume fraction in solids. So what I can see here, if I want to find the volume fraction in solid, so it is equal to C. This is the Cl minus, this is C minus Cl divided by this Cs minus Cl. So this much distance. So you can see, if you want to find out the volume fraction in solid, it will be equal to this length divided by total length of the arm, isn't it? That is this opposite arm. So if I want to find out the volume fraction in solid, so it will be opposite arm divided by length of the arm. And for same condition, if I want to find out the volume fraction in liquid, so it will be C, this opposite R, this Cs minus C, this is divided by again Cs minus C, that is length of the arm. So in general way, I can write here the percentage or the volume fraction of the system. We can calculate it as the opposite distance divided by the whole distance, So dear students, this is known as the lever arm. So this is our lever arm move, opposite distance or opposite arm divided by the length of the lever. We are going to use it for the calculation or determining the phase fractions present in the system. So this is the lever arm. Thank you so much.